Okay, oh, lovely diagram in question 12. The diagram shows the curve and the normal to the curve show that the exact area of the shaded region is given by that expression there. Right, oh, what a nightmare. So we need to break it into two parts, don't we? That seems sensible. We have a part A, which is under the curve, or between the curve and the x-axis, and a part B, which looks to me very much like a right-angled triangle. So shall we work on the top bit first? The top bit, area A, is simply the integral between 0 and pi by 4 of that expression. There were some of you who overcomplicated this a little bit by trying to look for fancy things you could do with the double angle formulae and all that kind of thing. But quite simply, if you differentiate sine 2x, you get something related to cos 2x. It's a Craig's rule question. The top is closely related to the derivative of the bottom. In fact, if we write it as being, well, what would it need to be? Sine differentiates to cos, doesn't it? So sine 2x goes to 2 cos 2x. So that's a minus sine 2x. So that we need a minus 2 cos 2x on the top in order for the top to be the derivative of the bottom. Of course, I've just changed the value of the whole expression. We need to put a minus 2 in front of it there in order to keep everything going okay. So this is minus 2 times, so that's the natural log of 3 minus sine 2x between 0 and pi by 4. It is a detailed reasoning question, so we can't just throw this at our calculator, but that's all right, isn't it? If we start putting in those limits, that is the natural log of 3 minus sine, 3 minus the sine of 2 lots of pi by 4. That's pi by 2. Take away the natural log of 3 minus the sine of 0. Have you noticed, because it's detailed reasoning, I have decided to write in 3 minus sine 0 and not just know that that's 0 and I'm not going to bother with it. I'm showing all of my detailed reasoning because I'm good like that. So we've got minus 2, natural log, now sine of pi by 2, that's 90, sine 90 is 1. So that's natural log of 2. And here we've got 3 minus 0, so natural log of 3. That is minus 2 times the natural log of 2/3. But it's now going to be the natural log of 2/3 to the power of minus 2, because that's our other log law. The minus means we're going to take the reciprocal of that fraction, and the 2 means we're going to square it. So it's the natural log of 9/4. And we are feeling super good about that, because in the question, it had natural log of 9/4. So it's going great. Now we need to work out the area of that little triangle that I called area B. So let's focus on area B now. For what we've just done, we've got 4 marks out of the 10 that were available for that bit of work out that we've just done. So actually it's the harder bit that we're now dealing with. So that was the normal to the curve. If it's the normal to the curve, that's all about gradient. So I think I'm going to need to know what dy by dx is, so I can work out the gradient. Y was 4 cos 2x over 3 minus sine 2x. So if I'm going to find dy by dx, I'm going to need to do the quotient rule. Quite right. So the quotient rule is going to be v times du by dx. If I differentiate cos, oh, that goes to...
You need your CD music system.
Good call. CD music system, cos differentiates to minus sine. So that's going to be minus 8 sine 2x, because it's the 4 times 2, minus, that's v du by dx minus u dv by dx, and we've already actually differentiated the bottom earlier on. That is minus 2 cos 2x. So there we go. Divided by v squared. There we are, divided by v squared. Right. I could do a bit of work on simplifying this at this point. And in another question, I might have done that because it might have wanted to get an expression for dy by dx. But actually, the only thing I care about in this is what the gradient is like when x is pi by 4. So I'm not going to bother simplifying this because also it's all about sine and cos, and pi by 4 is a kind of, if I'm doubling it, it's a key number to be putting in there. So when x equals pi by 4, dy by dx is 3, we're still on detailed reasoning, so I'm being careful with this, 3 minus sine pi by 2 times minus 8 sine pi by 2, take away 4 cos pi by 2 times minus 2 cos pi by 2, all divided by 3 minus sine pi by 2 squared. Now I think I can do some working out with some of this stuff. Remember, sine of pi by 2 is 1, cos of pi by 2 is 0. So in all of this, I've got 3 minus 1 times minus 8. Take away 0, cos of pi by 2 is 0, so that's 0 times 0, divided by 3 minus 1 squared. That's negative 16 over 4, so minus 4 is the gradient of the curve at that point. And the diagram makes it look as though it might be. I want the normal, so the normal gradient is minus a quarter. So I'm now going to do y minus y1 is m x minus x1. It's not minus a quarter. Thanks, Danny. It's plus a quarter, which gives me y equals a quarter of x take away pi by 16. So that point down there in the triangle was pi by 16, minus pi by 16. So there's the little triangle that I'm talking about. This is the triangle that we call B. That distance is pi over 16. That distance is pi over 4. Area of the triangle is a half times the base times the height, which is pi squared over 128. Again, what a convenient number, because all we need to do now is say the total area is the first one plus the second one, and that was all we needed. There it all is. Good, 10 marks that, wasn't it? We got there. Okay. Any questions about that? Good. That's maths. I'm not writing QED.